Hi, we are from Group 10 in COA Section 4. My name is Ching and my teammate is Phang So today we are going to present about debugging process for Part B and Part C in Lab 1. So first, let's start with the Part B first. We will be using the program of add subject to the ASM that will perform some simple arithmetic that using 32-bit unsigned integer. So at dot data here, we will have our value 1, which holds the value of 10,000 in hexadecimal, value 2, 40,000 in hexadecimal, and value 3 that is equal to 20,000 in hexadecimal. Final value here is uninitialized yet, that's why we put a question mark over here. So next, before we move on to the instruction part, let's take a look over here. We can see that the value of the EAX in the autos is actually a random number because we haven't assigned EAX any value yet. So it is in a random number first. Okay, next. So the first instruction, we will be moving the value 1, which is the 10,000 into EAX. So let's press F10. Yes, the value of the EAX has become 10,000 in both autos and the register 2. 10,000 over here and 10,000 over here. Next, we will be adding the value 2 into EAX. So the value 2, which is the 40,000, value 2, 40,000 into EAX. So it will become 50,000 EAX in the autos and also in the register 2, 50,000. Next, we will be subtracting the value 3, which is the 20,000 in hexadecimal from EAX. If we press F10, we'll get 30,000, which is the result of 50,000 minusing or subtracting the 20,000 out, then we will get 30,000 in the autos and the register 2. Okay, so for the next instructions, we'll be moving the value of the EAX into the final value. So now currently, the value of the final value is actually at 0 value. So when we press F10, the value of the EAX has copied or has moved to final value, which is the 30,000. And we can see also at the memory here. This is the value of the final value, and this is the address of the final value. Next, we will be calling dump register. Okay, so when we stop and then we compile and debug. Compile. Debug, start without debugging. And this is our call dump register function where it can help to display the register. We got our EAX is 3000. So that's all from part B. Next, I will pass the part C to my teammate.
So let's move to part C. So now I will start the debugging for part C. So here you can see the yellow arrow has been pointed to the line 22. So this gives the instruction is the val W1 will, the value of val W1 will be moved to the AX. So you can see at here the auto here, the value has been randomly assigned because we yet to start any action. So after I press my F10, you will see the value has been changed to 1000. So it means that the value has been successfully to move to AX. So let's go to the next instruction. So it gives the instruction like the val W2 value will be moved into the AX. And and the adding operation will start. So after I press the button, so you can see the value has been changed to 5000. Okay, let's move to the next line. So this line will be give the instruction like the value of W3 will be subtract with the AX. So after I press it, you can see the value also changed to 3000. So now in this line, we want to move the value of AX into the final val W. So we can see after I press it, yeah, the value has been successfully moved into that. So now we can trace the address of final val W. So following by the little endian rule, you can see that the low order address of 3000, which means the 00 have been fulfilled the first address, the first place, and following by the 13. Okay. So now want to print the we want to call the dumb read to display at the register. Okay. So now is the so now I will finish the part one of the passy. So let's move to the next part. Okay. You can see the yellow arrow has been pointed to the line 28. So it gives an instruction like the val v1 or the value of val v1 have moved to the a hash. So after I press the F10, you can see the value have been changed. Okay, so go to the next line. Okay, it gives an instruction like the value of val v2 have adding with the a hash value. So after I press it, you can see the value have been changed to 15. And the P means that the value of 15 in the ASCII code, it will present as P. So, okay. Next, go to the line 30. So, at the line, it, it gives the instruction like the value of while V3 have to subtract with the A hash. So, after I press it, the value becomes 13. So, now we have to move the value of A hash into final val B. After I press it, you can see that the value of final val B have been changed to 13, and it will display as 0 followed by the ASCII code table. Okay. So now we have to call dump register to display the value to display the value at register. So as usual, we can trace the address of the final val B. So you can see also following by the and then rule. So the 13 will be filled to the low address part and following by double zero. And the zero means that the 13 represent in the ASCII code. So that's all for our debugging part. Okay, thank you.
Thank you.